Edoardo, are you ready?
I am.
OK. The floor is all yours. Oops.
Thank you. So, thank you for being here, even if it's lunchtime, or at least in Italy it's lunchtime. I don't think that in Amsterdam it's lunchtime, but OK, thank you for being here. I would love to talk to you about this challenge that I impose on myself, like learning how bundlers are made and how bundlers work inside. Because I decided to do this because, in Storyblok, where I work, Storyblok is a product, it's a headless CMS, right? We have a ecosystem of open source packages, and we decided to migrate every package to Vite. And so I wanted to understand how Vite works, why Vite is different than other bundlers, and to better understand how Vite works and why it's different, I needed to first understand how bundlers work, why we decided to make bundlers, and how they work internally. And to do so, I decided to create one, a simple one. We'll get to that, but the agenda for today will be this. So we will understand why. I think we all know why bundlers were made, but just a little recap. We will see how to make a simple one. We will add some advanced concepts on top of it, and then we'll see why Vite is different. Right, so let's start with looking at a simple app from not that much years ago. You all see the code, right? It's OK. Not that much years ago, a JavaScript application for the web was looking similar to this. Many JavaScript files loaded in an HTML file. Probably your index.js was here, and then you had other dependencies. So for example, in this application, in each dependency, we have like functions, we have objects to configure, we have variables. And then, so in our main, in our index, we can call the functions, because they are defined global. And so if we do that, like if we go to this, we launch this, and we loaded the browser, the application works. But what's the problem here? The problem is this is not reliable. We cannot control the order of execution of our functions. We cannot control which function will get executed first, last, because everything is global. So this function, for example, which one are we calling? From which file? We are not explicitly importing files. Everything is global. So we can have variable name conflict. We can have function overriding, the pollution of the global namespace, and we cannot control the dependency order. We actually solved many of these issues. See why? With this improvement, the introduction of modules. With modules, you just can load an entry point, index.js in this example, and if you use the type module, the browser knows that this is an ES module feature that they have to apply. So here, we can explicitly import functions and variables from specific files. We can even rename them. So we can control the order of the dependencies, and we control exactly which one are we calling for functions and for variables, right? So this is reliable. So if we go to the second example, we load the server. We have still the application working, but this time, this is reliable. We know exactly what's happening, which functions are we calling, which variables. But we still have some issues. Let's start from the browser compatibility. Well, actually, this is not an issue, or it should not be an issue, because this was introduced in ES 2015. So major browsers started implementing it from 2016, 17. So now all major browsers support this feature. So we can say this is solved, unless you really have to work with older browsers or some mobile browsers, right? But what about performance? let's look at this. If you import many functions and many variables from various files, you still have many calls, many HTTP calls. Of course, you may say, well, today we should be using HTTP 2, so probably we have just one call. It's OK, it's true, but still, we have to load individual files, and these calls can fail for whatever reason. So this is not completely reliable. And also, if we just need a tiny function from a large file, the browser still loads the entire file. So we need something better. That's why bundlers were made in the beginning. We wanted a way to pack everything together in a single file, optimized, and so to improve performance and reliability. So we want to have something like this. This is an actual build output from a Storyblock JavaScript library. We want to get there. We want to understand how bundlers create this file. This is a single file. This is optimized. Everything bundled together, packed. So I created this MIDI bundler to show you how this is done. The architecture of a bundler, this is heavily inspired by Webpack, earlier version of Webpack. Now Webpack is a bit more complicated, but earlier versions of Webpack. We need just an entry point, entry file, and an output path. And we want to build a dependency graph starting from the entry point, the entry file. We want to understand what are the imports that this file needs and what are the exports that the file provides. So we need to start reading a file, parsing the file, and constructing a structure of every exports, every imports, a way for our bundler to understand what's important, what's exported, and to pack everything together. So this is simple, because we have many techniques to traverse files and to build a single one. This is more or less how Webpack works. I will show you the code, but we just construct the bundler, we pass an entry point, and we bundle for an output path. Let's see how it's done very quickly. I will leave you with the GitHub code for this. But sorry, the core part, as I mentioned, is to build a dependency graph. So this is very similar to what Webpack was doing and is still doing. We build a structure, an object, a JavaScript object. The keys of the object are the paths of each module or each files of our application. The value of the object is something for us to understand what to build. So we need the content of the module. We need an array of all the dependencies, the imports, and the exports. So if we are able to build this, we can then traverse this for every module, and we can build the whole bundle. To help us doing this, you see, this is how we read the file and we construct. This is very simple. This is not, of course, how modern bundlers do things. We just use a regexp. Of course, I used AI to build this regexp. So we can find imports and exports. A cool thing is this, and this is also how Webpack works. Since we have this structure, this object, with keys, content, dependencies, we need to implement something simple for the browser to read the exports and imports and place it in our bundle, executing it. This is the approach that we use and that Webpack uses. We have this common JS style function called require. And we simply just take the content of the function that we need and put it in the bundle where we need it. So we can also use named exports, named imports, aliases, defaults. We simply put this function on top of our bundle, and everything comes after that. So let's have a look. a simple bundle. Now we run the bundle. We have this folder with the bundle created. And you see that we put the require function on top. And now we have the object of all our modules. The keys are bundle modules path. And inside, we have the content. And we used our require function. The pattern here is the IIFE. So this is a function that auto-executes, right? So the browser simply loading this file, executes this file, and every module in our bundle is capable of just importing what it needs from others using our require. This is a clever and simple approach. This is what Webpack is doing. So this is similar to Webpack. Let's look at the comparison with the original Webpack. You see the Webpack require function is our require. And then on the bottom, we have our index.js with this structure. So we build a dependency graph. We bundle everything together, and we put them in a file telling the browser how to run it with auto-executing functions. Of course, there are modern bundlers today, like we have Webpack 5. I will go quickly through this, but just to understand that the concepts stays the same. We just have a more sophisticated approaches, like Webpack 5 have a more sophisticated module system, code splitting, hot module replacement, assets, chunk loading, tree shaking, and plugins. We will see how to do that. Other examples, Rollup. Rollup is optimized for ES modules that we saw before. It's better optimized, tree shaking. Then we have ES Build, always a bundler, but it's written in Go, so it's optimized for performance. Using Go, it can do parallel processing, native support for TypeScript, and bundles are optimized. Let's go back at how are we parsing code, because we are parsing code using regular expressions. But we cannot do that. This is not reliable, and for performance, this is bad. So modern bundlers use a concept called the abstract syntax tree. The AST is a structure that represents your text, your code, using nodes. Each node is an element, is a statement in your code, and that statement is represented through a verb in a formal language. So, for example, this is a simple JavaScript snippet with a sum and conditional and console log. This is represented as this abstract syntax tree with statements. And so for a machine, it's really easy to traverse this tree, and really fast. And just for you to better understand how a tree is made, this is a visual representation. So it's really easy to see if there are dead branches or something that can be optimized. And this is how modern bundlers do things. So you may ask if we are going to implement this pattern in our bundler. Well, there are parsers already available on the market that we can use. And there are widely used parsers, like Acorn, which is lightweight and fast. It's made in JavaScript. And there's Babel parser. So, for example, using Acorn, you just have to require Acorn. And with the parse function, you just get the abstract syntax tree out of it. So we could use this in our bundle. No, because it's time-consuming. But we can use something, because we want to get to this. We still want to have something optimized. Instead, we have this right now. This is not optimized. So we can use Terser. Terser is another JavaScript module, JavaScript package that uses Acorn, actually, and provides some APIs, some functions for us to transform, optimize, minify, do things on our code. So this is also what Webpack uses. Webpack uses Terser as a plugin to do things, optimize the code. To do things similar to what Webpack is doing, we can implement a simple plugin system and plug Terser into our simple bundler. So let's see the definitive extended bundler. So you see that to implement a plugin, I just require Terser, and I implement hooks. Hooks are really simple. Hooks are just functions with a random name that you choose. And a hook system is just that your main module calls a function by names. If you implement, or if some plugin implement that name function, it gets executed. You put something in input, and you expect something in output. So in this case, we are implementing a bundle hook, right? Because we want to minify the bundle right before it's written on the disk. So, of course, you can implement hooks wherever you want in your bundle process. This is implementing in the end. So with this simple function, we created the Terser plugin. And I just added a configuration file with an array of plugins so that now my bundler goes through this array, executes these functions, and if they implement my hooks, they get executed. In particular, we are calling the compress function of Terser, telling that I want to eliminate that code, and I don't want to drop the console because my app is working with the console. I also added something to not having to specify the entry point and the output in the command line. So this is all configured like you do with webpack, right? So now, this is just the plugin. Now, this is my bundle. This is very similar to what we had before. This is just to apply plugins. And we still have our regular expressions because it's too hard for the moment to substitute this. But let me see if I can go to the hook. OK. Here, before saving the file, writing the file to the system, we are calling apply plugin with a bundle hook. So the output file should now be optimized. So now if I go to my extended mini bundle and I run the bundler, now I created the dist folder with an optimized bundle. So this is more or less what I will get if I run webpack on this. And this is my simple bundle. This is the whole function, the whole application bundled together. This could be even optimized even more. But this is a single file with the whole application function that auto-executes. So now that we should understand how bundlers work, we can add and build some more advanced concepts on top of it. For example, tree shaking. Tree shaking is dead code elimination. So when we have a syntax tree, we know we can cut out dead branches. Like, for example, here we are defining some functions. We are not using them in a final application. So the bundle strips them out. We don't put it in a bundle. Code splitting. Code splitting is where, instead of having one single file for the bundle, we just split it in different chunks. This could be even done in our bundle. This is zero code, but just to see that we could, when we build a dependency graph, we could add something to build, to generate chunks instead of generate the whole bundle at once. And so the result would be like having the main bundle and then chunks. Then hot module replacement is where, you remember the structure, keys are modules. Instead of bundling everything together and serving everything together, if we serve them dynamically, we can even substitute a single module in real time. And this is done in development mode. We could construct a dev server. We could just spawn a socket, a web socket. So when we ask for a new module, when something changes, we can watch for changes using Chokidar, for example. We watch for changes. When something changes, we just push to the browser a new module. And we replace the module with the new one. So this is done with the dev server. Now, I think we should have a view of how bundlers are made. Modern bundlers even are made. Now let's talk about Vite, because Vite is different. Vite is a no bundler. They are calling it a no bundler. Why? Because, first of all, Vite works in two different modes, the dev mode and production mode. And they are different. For development mode, Vite is a dev server. You remember the web server, the WebSocket that we saw before. Vite is a web server in development mode. And it uses ES-build under the hood. So it's not a bundler. It uses bundlers, uses ES-build for development mode, pre-optimizing modules. And instead, when you build for production, Vite uses Rollup. So even the configuration for dev and production are different. Let's take a look at this. When we run our simple bundle, we have everything bundled together. Let's require something from Vue. Instead, in the dev mode of Vite, we are using ES modules. When you first run Vite in development mode, you will see this message, pre-bundling dependencies. This means that Vite is performing some pre-optimizations in modules. So if you look at the code, in our simple bundle, we just bundle everything together without optimizations. But Vite performs optimizations. So if you read where is Vite loading modules, it's actually loading them not from their original location, but from somewhere else, where Vite optimized the bundle first. So this is an optimized version of the bundle using ES-build. Instead, look at below. For production, we are using Rollup. So we have to configure Rollup for having the production bundle. In development mode, there's no bundle. There's a web server, a WebSocket, and files are transformed when we request it. So at each request, Vite transforms this file and serves them to us. So these two approaches are very different. Dev mode and production mode are very different. So with Vite, we have a faster dev startup and a better dev performance. So Vite was made with the developer experience in mind, right? And native ES module support. So in development mode, you will see ES modules. This is all built around ES modules. And since we are using modules and a development server, we have more accurate source maps. So for the developer experience, Vite is really better. Also, hot module replacement, since we are using transformations on the fly, it's better. Some downsides could be that we need modern browsers because we need to support ES modules, of course, WebSockets, and so on. But, OK, probably the vast majority of you could use modern browsers, so this should not be a problem. But if you need to support older browsers or mobile browsers, this can be an issue. And you need to keep in mind that there are differences between the dev mode and the prod mode. So the resulting application that you compile and serve to the browser when you are in dev mode can be different than what you have in production mode. You can even have a completely working development application, but in prod, it can break. The production build can break because the two bundles are different. They have different configurations. So before deploying an application built with Vite, always try in local environment or in a preview environment first. And still, this can be a downside in some situations. We don't have a single bundle in dev, so we have many HTTP requests. So still, we have to deal with many calls that can fail, that are less reliable. So this can be an issue, and I want to report this. Now, the whole code for the simple bundle is in GitHub. So if you want to just explore it for learning purposes, I put everything together in this GitHub repo. I am Edo. I'm a senior DevRel at Storyblock. You can find me on Mastodon. You can find me on YouTube and on LinkedIn if you want to connect. And remember that you can join the Storyblock community. So this is QR code of our community if you want to join, if you want to see what we are doing. And lastly, again, if you want to check out this bundle, I will leave this here. Thank you.